Hello friends, today's question: a coil of self-inductance of 10 millihenry and resistance zero point 0.1 ohm is connected through a switch to a battery of internal resistance zero point 0.9 ohm, after which, after the switch is closed, the time taken for the current to attain 80% of its saturation value is. So we have given that we have a resistor and inductor in a series. Along with it, we are also given a battery which is having some internal resistance. And let us suppose this is resistance, value is given as 0.1 ohm, inductor whose value is given as 10 millihenry, and we have a supply voltage, let us suppose that is V, and internal resistance of this is given as 0.9 ohm. And yeah, that's all the things that are given to us. So in this case, we are set to find out when the current reaches the 80% of the saturation value. So first of all, let's find out what will be the total resistance of the circuit. Total resistance of circuit, let us call that RT, that is our total, will be equal to R plus small r, and that is 0.1 plus 0.9, and this gives us that our total will be equal to 1 ohm. We will be also requiring the time constant. So let us find out the time constant of the circuit. Time constant of RL circuit, that is represented as tau. So tau will be equal to L divided by RT. Inductor is given as 10 millihenry and this is 1 ohm. So we get the time constant tau will be over 10 milliseconds. Now the equation of the current, rather we can say current growth equation in the RL circuit, you can say current growth equation in RL circuit, we can write that our I will be equal to I max. Sometimes it is also written as I naught, and this is 1 minus e raised to power minus t upon tau. And here I max is our maximum or steady state current. Maximum, or we can also call it as steady state current. And we need to find out when its value is 80%. So we say the current reaches 80% of the saturation value therefore I will be equal to 0.8 of the maximum value of the current. So we substitute the values, we get that our 0.8 I max will be equal to our I max, and this is 1 minus e raised to power t divided by tau. I max and I max cancel with each other, and we can simply further simplify and write it as that e raised to power minus t upon tau will be equal to 1 minus 0.8, which comes as 0.2. And we do you can say a little bit manipulation. We can write this as t upon tau will be equal to natural log of 0.2, and this can be written as minus t upon tau will be equal to minus natural log of 5, whose value is given to us. This minus and minus cancel out, and we get t upon tau will be equal to values given to us, that is 1.6. For t will be equal to 1.6 multiplied by tau. So we get from here t is equal to 1.6 into 10 into 10 raised to the power minus 3 seconds. Therefore, we can write our t will be equal to 1.6. Sorry, not 1.6, but 16 millisecond. 16 milliseconds. And the options that are given to us is our D option is the correct one. Okay, so we can write this as, not in millisecond, we can write this as 0.016 seconds. So therefore the option D is the correct one. Option D is correct. So this completes the question. Thank you.